Assalamu alaikum dear students. Today we are going to discuss another test which is called as the second derivative test to check which point is local maxima or local minima. Now let f be a function defined on interval I such that c is the interior point of this interval, and at c this f is twice differentiable. Then first postulate of this test is that x equals to c is the point of local maximum, or it is the point of local maxima. If f dash of c equals to 0 means f is critical point and second derivative at c is less than 0. So this means that second derivative at c is negative. Then the value f of c is called as the local maximum value, while as point c is called as the local maxima. Now if x equals to c is 0 means if f is critical point, and the double derivative means that f double dash of c is greater than 0. This means that this x equals to c is the point of local minima and f of c is the local minimum value. This test fails if f dash of c equals to 0 and if f double dash of c equals to 0. So we cannot say anything about c if f dash of c is 0 or and f double dash of c is 0. Like if we consider an example, f of x equals to 9x square plus 12x plus 2, then its derivative by differentiating it is 9 2s are 18x plus 12. Now for f dash of x equals to 0 more for critical point is x equals to minus 2 upon 3. Also f double dash of x is 18, which implies that at x equals to minus 2 by 3, f double dash of minus 2 by 3 is 18 because 18 is constant which is positive. Hence by second derivative test, x equals to minus 2 upon 3 is the local minimum value, because it is positive by second postulate of this second derivative test. So this means that x equals to minus 2 by 3 is local minima, and local minimum value is by substituting x equals to minus 2 by 3 in given function, which is after this multiplication it is minus 2. So we cannot say anything about local maxima because second derivative test, in second derivative test if we have to check the point, it should be the critical point, because here we have only one critical point, so we can only say about this point, that is local minima point. Like if we consider another example, f of x equals to 2x cube minus 6x square plus 6x plus 5. Its derivative is by differentiating this equation with respect to x, which is 6x square minus 12x plus 6. For critical point, its derivative is 0 minus 6x square minus 12x plus 6 is 0, or simply x minus 1 whole square is 0, or x equals to 1, x equals to 1. This means that it has one critical point which is repeated twice. Now also double derivative means when we differentiate this again with respect to x, that is differentiating f dash, we get f double dash of x, which is 2 into x minus 1. Now at x equals to 1, f double dash of 1 is 0. Hence we cannot apply here the second derivative test, because f dash of 1 is 0, while as f dash of 1 is f double dash of 1 is also 0. This means that we cannot apply second derivative test. Hence we shall apply the first derivative test to check whether this point is local maxima or local minima. Now clearly from these two examples, second derivative test is little bit easier test than this first derivative test. Now consider another concept, like if we consider function f of x equals to x plus 1 in open interval 0 to, we cannot use here first and second derivative test, because when we differentiate this we cannot get the critical points, because it has no critical point. Also its maximum and minimum values does not exist, because it is continuous and it is increasing function. We that for increasing functions, the critical point exists at the end point. This the maximum and the minimum value exists at the end points. But if we extend its domain, that is we consider it is closed interval 0 2 as a domain, then this function has the minimum value at x equals to 0, while as maximum value at x equals to 2, which is 3, and the minimum value is 1. Now, like if we consider the graph of the function f of x in closed interval, means whose domain is closed interval a b. Now, at a value is f of a, which is maximum among all the values. At b, it is minimum among all the values. This at c1 and c2, it has local maxima and the minima at c1 and c2. This means that f of a is the maximum value of f at x equals to a. F of c2, here this value, it is the local maximum value at x equals to c2, because by the derivative tests, which implies that f of a is greatest among all such values, all such local maximum values. Then this value is called as the absolute maximum value, or simply the supremum of a function. So what is absolute maximum value? Absolute maximum value is the greatest among all the local maximas or maximum value. Similarly, here f of c1 is local minimum value at c1. F of b is the minimum value of this function at b. Now f of b is least among all these values, all such values, all such minimum values. This f of b is called as the absolute minimum value. So for increasing and decreasing, if we have an increasing or decreasing function which is defined on closed interval, then absolute maximum and the absolute minimum value exists. This exists at endpoints. So at endpoints, if we have increasing and decreasing function, it exists at the endpoints of the domain. Now if we consider closed interval, continuous function on closed interval, then if it is increasing, then it is endpoints. At endpoints, it is the maximum and the minimum, absolute maximum and the absolute minimum value exists at the endpoints. But if it's simply continuous, the absolute maximum and the absolute minimum value exists at a point only once, although the local maximas and the local minimas exists at more than one point of the domain. Now, if local maxima or this absolute maximum or the absolute minimum value exists at the interior point, then it must be the critical point, because at this point the function changes its behavior. That is, f dash of c must be 0 when c absolute maximum or the absolute minimum value exists, while c is the interior point, means c lies within this, not c is not the end point. Now how to calculate this absolute maximum or the absolute minimum value? Now there is a rule on the closed interval. Now firstly we have to locate the points where the derivative is 0. That is, we have to find the critical points, or those points where f is not differentiable. Now take the endpoints of the interval. Now calculate step third. Calculate the value of f at these points which are identified in step first and step second. That is, we calculate the value of f at points which are the critical points, and or at the points where the function is not differentiable, or at the end points of this domain. Now when we calculate the value at these points, the maximum among these values is called as the absolute maximum value, while as the minimum among these is called as the absolute minimum value. Like if we consider an example, x square plus 2x plus 1 in interval minus 2 to 1, f dash of x is 2x plus 2. Now for critical points, derivative is 0 minus 2x plus 2 is 0, which implies that x equals to 1. So this means that it has only one critical point, that is x equals to minus 1. Also it is differentiable, so this means that there does not exist any point at which f is not differentiable. Hence we will find this value at point minus 1, at point minus 2 and 1, because minus 1 is the critical point, minus 2 and 1 are the endpoints of domain. So when we calculate the value, f of minus 1 is 0, f of minus 2 is 1, f of 1 is 4. So absolute maximum, that is maximum among these three numbers, is 4. Hence 4 is the absolute maximum value, while as minimum is 0. Hence absolute minimum value is 0, which is attained at x equals to minus 1, while as absolute maximum of this function is attained at point x equals to 1. So in this way we find, this is the rule to find the absolute maximum and the absolute minimum value of the function. So thank you.